This is a review of the wastewater engineering course chemistry prerequisite sort test. So in the test that you found on Blackboard, first question is calculate the molecular weight of phosphate PO4 to minus, and the way to do this is to look at the molecular weight of phosphate equals or phosphate PO4 equals the molecular weight of the phosphate ion element and 4 oxygen elements. In order to find the molecular weight, we need to look at a periodic table of the elements. We can find the molecular weight of oxygen as listed here, 16 gram per mole. We have phosphorus here, around 31 gram per mole. So 1 phosphorus and 4 oxygen adds up to 95 gram per mole. Second question is, if I have 15 milligram of phosphate in water, how many milligram will be of phosphorus will be in 1 liter? So to answer that question, so I've got my concentration, we'd call it C1, 15 milligram phosphate per liter. This concentration is given as a weight of phosphate, so little m PO4 over the volume of the solvent. And in this case, we define the volume to be 1 liter. So that will allow me to find the mass of phosphate in 1 liter as the 1 liter times the concentration, which would be 15 milligram per liter, and then I would have 15 milligram of phosphate in 1 liter of solution. Now I want to know how many milligram of phosphorus I've got. In order to find that out, so my unknown is the mass of phosphorus. I know that for every mole of phosphate I have 1 mole of phosphorus. So the NP equals the NPO4, where N denotes the number of mole I've got. I also know that the mass, the relationship between number of moles and mass is given via the definition of the molar mass. The molar mass of a substance is equal to the mass of a substance divided by the number of moles that I've got of that substance, N. So looking for N, I can say that, well, my NPO4 will be equal to the mass of PO4 divided by the molar mass of PO4. Molar mass I found to be 95 gram per mole, and now the mass in 1 liter would be the 15 milligram. So I have 15 milligram, and I've got a molar mass of 95 gram per mole. 95 gram per mole equals 95 milligram per millimole. So this will allow me to find the result here in millimole, being 0.16 millimole PO4. I now know that every time I have 1 millimole of PO4, I have 1 millimole of phosphorus. So the mass of phosphorus that I've got here equals the number of moles of phosphorus times the molar mass of phosphorus. Now the number of moles, as I said, is 1 to 1, so 0.16 millimole of P, and then I multiply with the molar mass of phosphorus, which is 31 milligram per millimole, and units add up, and I end up with a result here of 4.9 milligram of P in my solution. So question 3 was how many millimole is in the solution from question 2, and this answer I've got calculated here. So I have the result from question 3 being 0.16 millimole of phosphorus. I could also calculate this as well. The number of moles would be the mass divided by the molar mass, and here I've got the mass to be 4.9 milligram, and I have my molar mass 31 milligram per millimole, and that would give me again the 0.16. So, but I had it up here. Question 4. I have now got this nitrification reaction, NH4+, which is the ammonia, that can be oxidized with oxygen. If we have oxygen available and some microbes, they will take action and transfer the nitrogen into nitrate and some water and some H2+ or acid. So I'm interested in figuring out how much oxygen I use every time I oxidize 1 gram of nitrogen. So from my reaction, my balanced reaction here, I can see I have a molar ratio of 2:1. So I know that every time I oxidize 1 mole of ammonia, I use 2 mole of oxygen. I want to know how much mass that is. So in 1 mole of NH4, I have 1 mole N, and the mass of that would be the molar mass. The mass of 1 mole is the molar mass, because N is equal to 1, and that is, looking in the periodic table of the element, it's 14 grams. So 2 moles of oxygen, same. What is the mass of 2 moles of oxygen? Well, the mass here is 2 moles times the molar mass of oxygen. So 2 times 16 gram per mole. That will be 64 gram of oxygen. So 2 mole of oxygen equals 64 gram. And the mass of oxygen per mass of nitrogen in the reaction up here then becomes 64 grams of oxygen used for every 14 grams of nitrogen nitrified, equal to 4.57 grams of oxygen per gram of nitrogen, which will be my result then. So that was question 4. Question 5. The question here is whether this will affect the pH, and as I can see here, the oxidation of ammonia will result in acid formation H+, so addition of H+ will lead to a lowering of the pH, so this will result in a lowering of the pH, as the pH is defined as the minus logarithm to the concentration of H+. So producing more of this, the minus log will be smaller and pH is dropping. Question 6. What drives the transport in the process of diffusion? Well, the question here is that the Fick's law says that the transport of substance with diffusion depends on the diffusivity of the substance and the concentration gradient. So the transport, if you like, the velocity here will be equal to, it will be depending on the concentration gradient, so that's the correct answer. 7. What matters in the transport of substances by diffusion? So molecular diffusion, the diffusivity constant of a substance depends on the substance itself. It depends on what solute we've got, so is it going on, is diffusion going on in water or in air, for instance, and very much also of the temperature. So these three answers are correct. Pressure does not influence diffusion in general. Question 8 being perhaps the more complicated one. So the right answers here was the solvent type, temperature, and substance diffusing. So the yeah, well, that's the solute. Yeah. Right. Question 8, a little bit more complex here. I have a concentration given of my aluminum chloride, which is said to be 10% by weight. Weight. What does that mean? Well, this means that I have got 10% of the solution, the mass of the solution is aluminum chloride. So this means I have 0.1 kilogram of aluminum chloride per kilogram of solution. 1 kilogram of solution gives me 0.1 kilogram of aluminum chloride. That's a 10% weight solution. Now I want to know how much volume of this solution I will need to produce a mass of aluminum that's 100 gram. So a volume times a concentration, that will give me a mass of aluminum equal to 100 gram. The concentration here will need to be in a different unit than the concentration up here in order for this equation to add up. And I'm given the volume here is 1 liter of solution. And I know how much I want. So I have only one unknown here, and that's this constant. Well, no, sorry, this is the unknown, the volume. I don't have that given. So I want to know how much solution I need. The concentration here I can derive with a concentration in the right units from this. So that's actually the task. I need to go from a concentration given in 1 unit to a concentration in gram per liter in order for this equation to make sense and for me to be able to calculate my volume. So you could say my needed concentration here has to have the unit of mass of aluminum per volume of solute. So that's the situation. And I then know my 100 gram, and I know my yeah, I can calculate this derived. So I need to start out with this definition of my concentration 1 that was defined as that I have mass of aluminum chloride per mass of solvent, and this was 0.1 gram per gram or kilo per kilo or whatever, 10%. I have information about the density of the solution. The density is defined as the mass of the solvent divided by the volume of the solvent, so the solution. So mass per volume, and that was given as 1.2 kilogram per liter. So if I take my concentration again and I say, well, this can be written as the mass of the aluminum chloride divided now by the volume of the solution times 1.2 kilogram per liter. So I've substituted the mass by the volume times the density. Now I also have to look at transferring the mass of aluminum chloride to the mass of aluminum. I need to look at the ratio between the two. I know that for every mole of aluminum chloride I take in this solution, I have 1 mole of aluminum. So that's the key to it, that in aluminum chloride, the aluminum chloride, so I have 1 mole of aluminum for every mole of aluminum chloride. So there's an 1-to-1 ratio between the two. The number of moles is equal to the mass divided by the molar mass, so the mass of aluminum chloride by the molar mass of aluminum chloride, and that will be then equal to the mass of aluminum divided by the molar mass of aluminum. Here I know in the solution, if I take, I know the mass of aluminum I have in my solution, aluminum chloride, sorry, and then I can find the molar mass of aluminum chloride, I can find the molar mass of aluminum, so I can end up finding the mass of aluminum. So my mass of aluminum chloride can be written as the molar mass from this equation. If I isolate this, I just multiply over with this, then I have the molar mass of aluminum chloride divided by the mass of aluminum, molar mass of aluminum times the mass of aluminum. Looking up in the periodic table of the elements, I can find these numbers: 133.4 gram per mole and 27 gram per mole for aluminum. And then I've got my mass of aluminum here. So I can substitute in my equation this number here by this number over here, giving me a expression of the concentration as 133.4 over 27 times the mass of aluminum now, divided by the volume of the solution times my density. So now I'm getting close to what I wanted. This is my concentration too, mass of aluminum over V solvent. So now I have a relationship between the concentration given in the assignment and this concentration that I want. So I want to isolate this expression here. So C2 equal to mass of aluminum over solution can be written as C1 times 1.2 divided by this number here, so now I've got this relationship between C1 and C2, and since I know C1 being 0.1 kilo per kilo, and I now have got this 1.2 kilo per liter divided by, I get a concentration here that I can calculate, and that adds up to 0.0243, and that will then be kilogram aluminum per liter of solution. So I've got my concentration now, and if I go back to see, well, I needed to figure out how much volume I would need in order to have 100 gram of, so going from here to here, now I have my volume. I can isolate it. I have 100 gram of aluminum, and now I've got my C2 given down here, so I divide by, or I could say 0.0243 1 kilogram of aluminum, and now I divide by 0.02 for 3 kilogram aluminum per liter of solvent, and units add up, and I end up with 4.16 liters. So because you could say that this molar ratio between the weight of aluminum and the weight of aluminum chloride is almost a factor 4, so or almost a factor 5 actually. I end up with a volume that I need that is end up with this number here. So I need 4 liters to have 100 gram of aluminum. In the 4 liters I will have considerably more aluminum chloride, of course. So, but the question was the 100 gram of aluminum.